Hi folks, this is video number 7 in the playlist that's devoted to 3D Experience CATIA generative shape design uh, functionalities. The particular video deals with the selection of point tangent on a curve option. In the previous videos, I've discussed other options that you've got. When you go to the generative shape design and you select the wireframe tab, uh, you can find the point icon in there, and when you click on it, this dialog box opens up. There's a pull down menu that you can select the tangent on curve option. That is the focus of this video. I'm going to show you how this works and what it does. So let's go ahead to 3D Experience. I'm in generative shape design, as you can see, and uh, what I'm going to do is a couple of things. So for example, on that horizontal plane, I will uh, sketch. I'll sketch a curve. The curve has to be a planar curve. The curve that deals in this uh, uh, description has to be a planar curve. So let me make a spline, for example. Okay, all right. Now, in this plane, or let me exit. So there's my spline, and on the same plane, I will draw a different sketch, which is just a straight line, and exit. So I have a planar curve and a line that is in a plane, which is the same as what the sketch is in. Now, if you select the wireframe tab, here's the point, and if you click on it, you use the pull down menu, tangent on curve. It's asking for two things. What is the curve that you want to use? There's the curve. And what is the tangent direction that you want to use? In this particular case, there's only one line that I've got here. And this line happens to be, by the way, sitting in this same, the plane that the same sketch lies. There we are. Notice what happened. I got several tick marks here. There's 1, 2, 3, 4. What does that mean? If you look at this thing from the top, let's look at it from the top here. To see better what's going on. So if you draw a line, if you take this line and move it up so that it stays parallel with itself, it reaches this point and it becomes tangent to that curve. You move it up again, it reaches this point and it's still tangent to the curve. Move up, tangent. Move up, you reach this one. So there are 4 points that if you draw the tangent line, it becomes parallel to this. Okay? So essentially, that's what the word tangent on a curve means. So let me go and make the. Oh, by the way, when you click on it, it says that there are multiple solutions here. There are 4 answers. Do you want to keep them all, for example? Do you want to keep them all? If you say all, it's going to keep all those four points. But if you say keep only one sub-element using near or far, so let me use this option, which is actually what's activated here, and it says okay. I say okay. It says okay. Do you want to first select your reference? So reference, for example, I can use this line. See that line? This line, we're going to select this line. And it says, do you want it to the nearest one or the farthest one? Nearest one is right here. And if you say far, it's over there. So the choice is yours. You can keep them all or you can select among them. Now, let's make this a bit more interesting. So let me go ahead and I'm going to delete this. Okay. And yeah, I'm going to delete that too. Remember this line this sketch 2 was that line. So I'm going to delete this and go back to space. Now draw an arbitrary line that is not even sitting in this plane or any plane that's parallel to it. So just an arbitrary line. So let me go ahead and do that. We go to, for example, I go to the vertical line, vertical plane, draw a line here and exit. So now I have a line that is not even in the plane of this this sketch, this two-dimensional sketch. Okay. To show you what happens better, let me find the projection. Let me find the projection of this line. Projection of this line on that plane. So how do we do that? We go to wireframe. Here is a project. Okay, and I want projection of this line on that plane that the curve sits in. There we are. So this is the projection of that line in that plane. Now, when I go to point, for the curve I select the spline, and for the tangent direction I select this line that is at an arbitrary angle. Notice that it finds these points. You might say, well, what happened? Where did these points come from? That's because it finds it finds it uses the projection line. It uses the projection line in order to find these points. Just like case 1 that I did, except that in case 1, I drew that line in the plane of the spline. Here, the line that I selected is not in that plane, but what it does, it finds the projection line, which is now in the plane of the spline, and repeats what we did in the first part of the video. Okay? That's where it is. Now, incidentally, if the line does not have a projection, it's going to come back and say, I can't do it. Let me first of all select, say all. Okay, let me go draw another line. This vertical line, or this vertical plane, I'll draw a line vertically up. Okay. All right, so exit. So now the line that I have, let me hide these things. Hide. So now I have a line whose projection onto the plane of the spline is just a single point. If I try to do that, so point, tangent on curve, here is the curve, the line is that vertical line, the projection, I can't do that. Because remember, the key was to project it into the plane of the spline, or into that two-dimensional plane, and then use whatever I did in the first part of the video. In other words, find tangents, location of the tangents to the curve, which are parallel to that projection. But you can't do it here, because the projection is not actually a line, it's just a point. That's pretty much it. Good luck.